All right, so we're recording, so mind what you say. Welcome everybody. This is our February 2024 meetup for the Kubernetes Atlanta Meetup. We're going to jump in. We have great content today, but first we want to start off as we usually do and thank our sponsors. First, big thanks to Sarah and Solo.io for sponsoring food and drinks and such, and flying Christian out here to speak to us. SpeedScale and Georgia Tech ATDC, thank you for coordination, orchestration, and physical space. And Calendly, thank you for allowing us to use your Zoom webinar to record this and host it so we can keep our virtual people connected. And with that, we're going to jump into our normal community news section with this month in Kubernetes. So we're currently in the 1.30 release cycle. And the next deadline is for exception requests. It's due by February 26th. We're currently tracking about 56 enhancements out of a total of like 80 something plans. So there's like 23 people that they get their stuff in. So if you got stuff going on with enhancements, make sure you get all the I's dotted and T's crossed with that. We did have some fixed releases within the past 30 days since we last met. Those go back to Kubernetes version 1.26. This is the last fixed release for Kubernetes 1.26, I believe. So it's kind of marked in life now. If you're on that, make sure you're doing what you can to get upgraded to 1.27 higher. So going into promotions, deprecations, the NA here does not mean that there was nothing promoted or nothing deprecated. There was just nothing that seemed interesting to me that I wanted to share with you. And CVEs, we did have kind of a major CVE within the community here with regards to Run C, and this is the leaky vessels titled CVE here. Pretty nasty one that allows for like container escapage and whatnot. Not going to go into a bunch of details because some of it's just way over my head. But I got a nice link here if you do want to geek out and read the details of it. It's out there. I think most of the managed Kubernetes platforms, most OS vendors that package Kubernetes binaries have fixes out there for this, or currency binaries have fixes out there for this. So definitely upgrade. There's some nasty stuff that can happen if you don't. PRs of note. So kubectl explain now shows enum values for CRDs. This one was really cool for me as somebody that does a lot of work with like Kubernetes operators and controllers and things of that nature. Essentially, hopefully everybody's familiar, or most people are familiar with the concept of kubectl explain. So kubectl being the command line utility to interface with Kubernetes. Explain basically takes a Kubernetes API type and prints out all of the information about it, what the fields are as part of it. So if you've ever looked at like a Kubernetes YAML manifest and been like, how am I ever going to memorize all of these fields and whatnot? You don't. There's too many. So you use like something like kubectl explain so you can get the information and kind of build that dynamically. And historically, when you do a kubectl explain on something like a pod, you get a field and what type it is. If it's a string or a Boolean or integer or something like that. But if it's an enumerated field where you have like specific options, you didn't know about that necessarily. Now, when you do a kubectl explain, it will actually print out the enumerated values for that specific field, which is super handy. So nice to see enhancements going in to continue to help with usability of some of these tools. Next, a KEP of note here. So that's a Kubernetes enhancement proposal, mutating admission policies. So this is related to some newer work. There's validating admission policies and now mutating admission policies. And these are a little bit different than some of the things you might be familiar with in name of like mutating admission controllers, validating admission controllers. But since the Kubernetes project adopted the cell language in certain parts of the project, they're continuing to enhance those capabilities here. And basically, rather than creating your own mutating admission controller, that you have to build and deploy and package and all that stuff in your cluster, you can actually just define the policy using the cell language. And there's a built-in controller that will actually implement that logic for you to do simple mutations. Now, not everything is available, so there's not direct parity with everything that you can do if you build your own mutating admission controller, but there's a lot of things that are like easy off the shelf if you want to just inject like labels or annotations or things like that. Super easy, so lowering the barrier to entry and the complexity required to get some of those features. So super cool. Next in the community news section, this is just some things that I found in and about the community that I thought were interesting. I'm not going to have any spicy hot takes from me today, but the Kubernetes network interface, KNI. So this is one that kind of, when I first saw it, I tilted my head sideways and it's like, huh? Because I'm familiar with CNI, the Kubernetes network interface. And essentially you can somewhat think about this as CNI 2.0. This is taking a more Kubernetes-centric approach to some of the networking concepts at a mid-level of the stack, if you will. So like CNIs today basically operate where Kubernetes doesn't care. Kubernetes is give me an IP, manipulate some IP table stuff, things like that. But that's about it. It's pretty transparent to Kubernetes as a process. So this allows for a little bit more tighter integration for certain features that Kubernetes needs to be aware of at the network layer, and the network layer needs to be aware of at the Kubernetes layer. And one of the things here, I also linked to this slide deck that one of the authors of this concept came through, and there's actually some really good diagrams and stuff in here that break this down and explain like what exactly are the pieces that account for the KNI layer versus the CNI layer, and things of that nature. So there's a lot of complexity in here, but it's very interesting. There's a lot of really cool features that can come about from having this kind of mutual awareness at a slightly different layer than we're used to operating at. And OpenFGA. So this is like relationship-based access control. This is an interesting one that, as somebody that's done a lot of work in the past in like the policy as code space, OPA and Rego comes to mind of like building policy and stuff. This is a little more finely scoped when it comes to access control and whatnot, but it's the project is based on the concepts from Google's Zanzibar white paper of this like relational access control thing. So basically, if you look at like Google Stack, they have all these different applications, but they have kind of a shared authentication and authorization layer. And a lot of that is basically what makes up that stack. And this is kind of an implementation of what was in that the details that were in that white paper in an open way. And so it basically gives you some things that you deploy running in your Kubernetes cluster, and some syntax and language and stuff to be able to specify your policy and relationship between entities and things like that. So pretty cool tool if you're working in complex authorizations, things like that. Might be something for you to check out. And I did link to the Google Zanzibar white paper there if you want to read all the fun academic side of things there. Next up, we have Gatekeeper Policy Manager. So extending on kind of the policy concept, this is essentially with Gatekeeper, you have constraints and constraint templates that are basically the policies that enact on the different objects within your Kubernetes cluster. And those are deployed as like custom resources into your cluster. And they have all these different sort of statuses of whether they're not they're enforcing or warning and different things like that. And this basically just provides right now a read-only front end. I'll eventually get down here where there's some screenshots. Here we go. A read-only front end to view the information about your constraint templates, policies that are being enacted on your cluster, what mode they're in, and different things like that. You can actually even view the Rego code for the policy itself in there. There's a lot of, if you take a look at the roadmap and the README here, there's a lot more of work intended down the road. If you've worked with like SPIRE's DAS, they're like online web portal that helps managing OPA policies and things like that. There's some similarities there, obviously not parity at any side, but pretty cool project. KubeShark, API traffic analyzer for Kubernetes. Disclaimer here, this is a paid for product. And I usually would never include a paid for product in here, but it was so cool, I had to. If you've used Wireshark in the general systems networking space to capture packet information and be able to analyze it, look at communication between source destination, things like that. This is this, but for Kubernetes API calls. And so it's a really nice tool that you can kind of have a piece running in your cluster. You can capture these, their capture format type and display it and kind of look at the stream of communication between different entities in the Kubernetes cluster. You can have it automatically and dynamically map out communication graphs for how information is being passed through into and around your cluster. And you can replay, like you can look back at like historical traffic information and whatnot with the Kubernetes API. And you can also have this kind of constantly running and feed it into external systems to historically track and graph out dashboards and things of that nature with it. But again, paid for product, so keep that in mind, but really cool. And then K8's network mapper, along the same vein. This was an interesting one, this Autorize company, organization, whatever you want to call. They have some interesting information where they kind of have some stuff in the RBAC authorization space, but they also have some API gateway stuff built on top of Envoy. But they released this network mapper utility that essentially you can deploy, use, I think like a CLI, or you can deploy it into your cluster, but it will basically just dynamically generate maps of like information about the services and how they talk to each other in your cluster. So also pretty cool. And they do have like a pay for enterprise thing where they'll make your graphs prettier in the cloud. So with that being said, that concludes our this month in Kubernetes section. If anybody in the community, either online or in the room, is hiring, please let me know. If you're online, post in the chat. Make sure you include information on who you are, how people can get in contact with you, what position you're hiring for, links to position descriptions, things like that. If you're in the room, find me. I'll take your information and get it down, and I'll post it in the meetup notes once it's done. And that being said, it's my pleasure to introduce a good friend of mine, Christian Posta from Solo.io. He's going to talk to us about cakes. So Christian, come on up.
He didn't bring any cakes. He's just going to talk about it. It's true. It's true.
All right. Well, first of all, I know how terrible the traffic is here in Atlanta. I really appreciate you all coming out tonight. We're going to be talking about a couple of open source projects that I put in the title. I don't have any cake. Sorry, that wasn't something that I planned for here. But we're going to be talking about a couple of open source networking projects, Cilium and Istio. I'm just curious, by show of hands, how many people are using Cilium today? Okay. How many people are using Istio today? We got two, one or two. Okay, all right. How many people have heard of Cilium or Istio? Okay, all right. They're two open source networking projects, like I said. They're part of the CNCF. There was some pretty big news this week about a networking project in the CNCF that just came out. A project called Linkerd decided that they're not going to do any more stable builds in the open source project. They're going to continue to open source, and they're going to continue to contribute to the open source. And they're going to do builds. They'll release builds, but they're going to be basically nightly builds. They call them edge builds, or whatever's on main. And if you want to get stable builds, you have to go pay for it from Atlanta. That's all I'll say about that, but that is important news, I think. And actually not too long, maybe it was last week or the week before, there was a big dust up in the Nginx community. One of the lead developers on the Nginx community said, I quit this community. The parent company of the Nginx company, F5, who bought the Nginx company, made some decisions about the project and open source governance that this particular contributor didn't agree with. He didn't feel like it was very community friendly. And we've seen this before, where single vendor backed open source projects, they succumb to the, the commercial whims or, desires of those companies. And so if you're looking to adopt open source, the health of the community is extremely important. Take into account when there are, not enough diversity in the community. Community and open source is very important. So my name is Christian Posta. I'm the global CTO at a networking company called Solo.io. At Solo, we build cloud networking products based on open source projects. We try to pick the ones that are healthy, that we will contribute to, that are sort of leaders in their categories. We feel like, for example, Istio and Cilium are two good examples of that. And we try to look at cloud networking in holistic. And we'll talk about what the cake stack is and why those open source projects we believe are the right ones to fill the needs that we need in modern cloud networking. We were a few of us were talking with Kelsey Hightower last week, and somebody asked him a question. It was, well, with all this innovation stuff happening in the networking space, where do you see networking in 5 years? And he gave a really good answer. You shouldn't know about it. It should just, fall into the boring parts of the infrastructure. You shouldn't even know about networking. But I don't think we're there. We're building stuff. We're trying to. How many of you in this room are part of a platform engineering effort in your organization? Couple, handful. Right. We are trying to build and productize a service to the rest of the developers. But I'm not seeing, myself at least, networking being a focus of that. What's going on? Good.
Slides. You keep talking.
I can't see the slides. I'm not going to keep talking.
So with Linkerd, with my understanding that I think like could I just fill over it? I would look at it very, usually people tell me to stay on things. Is it broken? No, leave it alone. So.
Google slide, but it's on Solo.
Really, but it's good, right?
All right, those technical difficulties.
That's right. Right?
Yeah.
So if your build ID is, that's what you do. You go find your build ID. Okay. Yeah.
Oh, and what's the email?
Yeah.
Oh, yeah, there's free index now or something like that, yeah.
Yeah, where's the free Linkerd? I'm gonna make the same release, you know?
Linker free.
Linkerd free. Somebody check, is that domain available?
The rest of that domain.
Alright. We're good? Can you sit on the?
Yes.
Okay. So I was saying we're starting to organize platform engineering efforts, but what I see is people working on things like containers, Kubernetes, CI/CD, networking sort of well, we'll get there. So I'm here to talk to you about open source projects that are sort of best of breed in their categories that better fit modern networking needs and fit into the platform engineering efforts and do so better than what we've traditionally had in the networking space. So we got to start with the motivation for why, because we have already invested a lot into networking in these large enterprises. How many of you would identify as working at a large enterprise? Yeah. So this might be familiar, but you'll know that at least the organizations that we talk with, they're looking to modernize by delivering software faster. They want to improve their experiences with their customers. I put up a few of the brands that I interacted with today or yesterday to get here. And all of them have mobile apps. All of them have done a lot to improve the experience, at least for when I was traveling, like when I landed here at the Atlanta airport and I pulled up Uber, I had no idea where the Uber pickup was. And I feel like they change it all the time anyway. And on the Uber app, it said, walk here, turn here, go this way. And to me, that was just a great experience. They thought ahead about that. But to build these types of engagements with their users, these organizations are building services, APIs, exposing data, exposing capabilities of their enterprise. And they're doing this more and more. We're getting a lot more services and a lot more APIs. They're using containers at times, maybe Lambdas, deploying on public cloud, and there's more of these things. But for these things to do anything, they need to connect. They need to communicate. And when they're deployed on this cloud infrastructure, there are some assumptions that we've had in the past that just don't hold today. And I'll talk a little bit about that. The current challenges that I see in our existing networking investment boil down to these 3 or 4 points. I'll talk about how organizations are structured and how that affects networking. I'll talk about sort of the way organizations think about adding new features and doing things that, the status quo, how that has a big impact on our networks. We'll talk a little bit more in depth about what those outdated assumptions are in the network. And then how, these different parts of the organization will care about what they care about and then leave the rest to the developers to try to figure out. Right, so the first point is a lot of these larger organizations, they have multiple different teams that are responsible for different areas of what we call the networking and security and compliance. You got the API management team, you got the networking infrastructure team, you have the InfoSec team. You might even have little offshoots of that security team, might have a completely different cloud platform team. And what we've seen in the past is that these individual parts of the organization, they make decisions and choose technology to satisfy the needs that they have without really discussing it with other parts of the organization. Right? We might pick things like firewalls or load balancers, and the API management team says, well, we want to kind of do it slightly different. the networking team says, well, security team told us we have to do this. Now we have to figure out how to integrate this. And a lot of times these big proprietary networking technologies were not really built with nice seamless integration in mind. And so getting those things to work together is painful, extremely painful. Right, so I'm sure you've heard the Conway's law that organizations that build systems are constrained to build communication structures and build the system the way that they're organized. And that's exactly what we see with our networking efforts. The second thing is when we get a pattern that works and we want to continue to add capabilities, then we just repeat that pattern. That's definitely what I've seen, right? You get a set of services to work, you got your Palo Alto firewalls and your F5 load balancers and deployed on Kubernetes or VMs, it doesn't matter. Now you want to build more services, well, you just spin up a new team, new line of business, new team. Same sort of pattern, a new team to manage and monitor all this stuff. And that ends up becoming massive sprawl across the organization. So now we have Conway's law that caused all this friction. We proliferate that pattern throughout the organization. And now being able to do consistent security, compliance, audit, integration, all of this stuff gets really, really hard. And then we deal with things that are just kind of slightly outdated. This idea that our networking assets or our assets can be secured by the network by putting a big wall around everything is slightly outdated, actually really outdated. The more we introduce things like extending out to the cloud, extending out to mobile devices, poking firewalls, poking holes in the firewall between all these systems, that perimeter starts to erode. Now we should be thinking about, well, what happens when something does breach the perimeter? What happens with their ability, an attacker's ability, for example, to move laterally and get to other systems within these segments? Another thing is in our traditional, the way we've always looked at networking, we've thought about policies in terms of things like IP addresses and firewall rules. And in a world like Kubernetes with containers and things are highly dynamic and ephemeral, where pods, for example, can be coming, going, scaling up, scaling down, IP addresses, recycling. This unit of control doesn't hold anymore. Now, in this very simple example, we have two services deployed potentially on two different hosts. The hosts have IP addresses. And what we end up doing is writing a policy that says service A can talk to service B. And we express the policy based on IP addresses. Well, if we deploy a service C to that second host, now we've unintentionally introduced service A can talk to service C, but we didn't expect that. From, for example, a compliance standpoint, we didn't expect that. And so now we get into this notion of what's called bit rot. You express something and then it slowly changes over time. And this can happen actually quite quickly in an enterprise environment, especially across all those different silos, across all those different cookie cutter stamp out islands, networking islands. Another example would be, well, what if those IP addresses get reassigned? And this happens in Kubernetes all the time. If a host goes down or a pod goes down and comes back up with a different IP address, but then the IP addresses that were relevant in a particular rule get assigned to something else, now you have a completely, potentially compliance violating scenario where service A can talk to service D because policy says these IP addresses can talk to each other when service A is not allowed to talk to service D. So where things run and policy built on location is an outdated assumption. in our modern context. What we care about is, what those things are, not where they are. The last bit that I've seen is we've seen these organizations put in the coarse-grained networking firewalls and API management and so on, and then just leaving authorization policies, all this other stuff to the applications. Let them figure it out. And across different languages, across different frameworks, different development teams, full-time employees, contractors, consultants, all of this stuff gets really, really inconsistent, really difficult to maintain. So this approach to networking is, in my opinion, for Kubernetes environments, modern platforms that we talked earlier about building, is outdated. The network matters a lot, and the network is not hidden away. If we ignore it, then we end up with all these weird security gremlins, load balancing issues, outages, potentially cascading outages. It's expensive, difficult to integrate. They weren't built for integration. And ultimately, this really slows down our ability to make changes and deliver software faster. That's what the business wants. This is not going to work. All right, so if we look at what we can do to improve, and we look at it through a first principles approach, then we can start to line up what technologies, what processes, what organizational changes might be necessary to kind of sort this out. Now, I'm definitely not going to sit here and tell you that if you adopt this technology, this is going to fix all your organizational problems, because that's just not possible. But I think the platform engineering efforts that we see going on in these different organizations is an existential proof that these organizational problems are a problem, that we need to address them, we need to improve them, and that's where the platform engineering teams come into the picture. These teams are commissioned or designed to be cross-functional, to work with developers, to improve their developer experience, so that they can accelerate their ability to deliver value. Now, they'll do things like build services, build tools, guardrails or gates for developers to be able to more quickly onboard and deliver changes. You'll see things like internal developer portals and CLIs and various tools for doing that. But the outcomes, what we want to see is improved developer performance, so we should be measuring that. Improved efficiencies and potentially cost savings because of that. Increased compliance, because that team sort of puts together the best practices for doing that. But from a technology standpoint, there are a few principles that I think are really important. The first is, instead of specifying low-level IP addresses and firewalls and all this stuff that make it very difficult to reason about what the intent is, what the posture should be, we should adopt things that look a little bit more declarative, that allow you to specify what the intention of the state of the system should be and allow you to compare that to what the real state is, right? This makes compliance easier. Easy, but easier, right? If we just throw a bunch of networking rules out there and say this is what it is without knowing exactly what our intention is, that makes it a lot harder. Building our policies, our security policies, based on what the workloads are, what they represent, what part of the organization they represent, and not where they happen to be deployed, what segment of the network they are, what IP address they are. That makes our policies more durable. So when things change, they fail, scale up, scale down, move different parts of maybe on premises to a public cloud, that our policies and our security rules stay intact. And the last is integration. We want easy, open, not easy, but open standard interfaces to be able to combine and compose different parts of the system or integrate with existing technologies. Right, so these three principles are, in my opinion, foundational. And if we look at how we're going to modernize our networking, these three have to be be there. All right, there's a lot of words on this slide. I really quickly just typed it out. But there is business value to doing this, right? And the platform engineering teams need to take this into account. That with control over our networks, observability in our networks, we can release faster. We can do things like canary releases. When we introduce new changes, we can compare that by looking at the observability and the metrics and the stats. We can observe what those new changes are doing to the system and compare them to the previous version. We can reduce the burden that the developers have to take on. I didn't write, there should be a third bullet there, security. Developers for things on the network shouldn't have to code that into their software. Improve compliance, reduce the time to recovery when things do go wrong through tracing, metrics, logging. Getting this consistent across every single developer and language and so on is extremely difficult. And then especially, in general, but especially when you're running in a public cloud where ingress costs and egress costs and location and failover and all this stuff become really important. You don't want to just leave that up to big centralized systems or developers. So the things that we do need API management. We do need to control ingress and egress. We do need things like policy management, mutual authentication, observability, service discovery, the ability to audit and log and track all of the the things that are happening in the network. So that is the buildup for why we want to even talk about networking technologies that better fit this this cloud paradigm. I mean, that's where the cakes stack comes into the picture. We tried to model it a little bit after the lamp stack and some of these other stacks where we identify and we pick the best of breed technologies for the particular layers that we think are relevant and make sure that they integrate and work nicely together. And in this case, they happen to follow those three principles that we talked about. Declarative configuration, workload identity, and standard integrations. So the C in the cake stack here is for Cilium, and we'll go into a little bit more detail about that. The A is for Ambient mesh, which is a sidecarless data plane option for the Istio service mesh. We'll talk a little bit more about those two. The K is for Kubernetes. This is a Kubernetes meetup. Hopefully I don't have to go into too much intro about that. Envoy proxy represents layer 7 capabilities in the network, and associated more so with API gateway and ingress egress type use cases. So the S and the last part here on this slide is for SPIFFE and SPIRE. I'm just kind of curious. You raise your hands. How many people have heard of SPIFFE and or SPIRE? Number of you. Okay. And that is the common thread of workload identity throughout our modern networking implementation. The way that we're going to walk through, and I'll walk through each of these and give notes about why we picked them or what their role is in the stack. But the way that we'll walk through it is bottom up here. And starting at the foundational layers where Kubernetes comes into the picture and working our way up. So we'll start with Kubernetes. Like I said, I'm not going to say too much about Kubernetes. It is the service orchestration abstraction that allows us to deploy services, start them, stop them, health check them, scale them, etc., in a common way, in a unified way. But the most important part about Kubernetes is it provides and performs the backplane or the backbone of our ability to write and store and reconcile declarative configurations. Kubernetes is based on a declarative configuration model out of the box. It has a standard way of integrating with it and extending it. And a number of these other parts in the layers, in the cake stack layer, build on that and extend from that. Another really important aspect of Kubernetes that, whether you agree or not, I've seen organizations use it for this, is to abstract away the compute layers in on-prem and public cloud. They want the idea is they want the ability to be able to deploy on a public cloud and maybe extend out to a different public cloud or work on premises and have some commonality between those environments. We also see Kubernetes as sort of the tip of the spear for platform teams moving forward and modernizing the way they build and run their applications. They'll build their CI/CD platforms around Kubernetes. They'll introduce new modern observability tools around Kubernetes. And it might start small, and you might only start with a handful of applications, but the idea is to use that as the sort of the bubble or the way to kind of strangle away some of the existing ways of deploying your applications. So little by little, lifting and shifting and moving your applications into Kubernetes will slowly grow that bubble. Right. So the next layer on top of that, since Kubernetes needs networking for pods and workloads to communicate with each other, they need a CNI, is where Cilium comes into the picture. Or the C layer in the cake stack comes into the picture. And we feel like Cilium is a really good CNI to fill that layer. The most important bits that we need from this layer are workload connectivity. And in Cilium's case, they use eBPF, which is a kernel layer technology that allows you to extend the kernel and optimize some of the networking paths between containers, for example, which then allows you to build up, just to higher levels of scale and keep your performance in certain envelopes and so on. So connectivity for the containers. We need things like network policy, so we can enforce sort of coarse grain layer 3, layer 4 type network policy. So if you're familiar with Kubernetes, the network policy object is implemented by Cilium. We noticed that Cilium gained a lot of adoption and interest in the community, that the public clouds, for example, Google is building their next generation container networking on top of Cilium. AWS is shipping Cilium as part of EKS Anywhere. Microsoft also is supporting this. So there's the public clouds sort of converged around the CNI to some degree. But at the end of the day, the C, just like in the LAMP stack, if you didn't want to use, P was for what, Perl originally? Yeah, if you didn't, or maybe it was PHP. Yeah, if you didn't want to use PHP, you'd swap it out and use Python or Perl or something that didn't start with a P, right? But in the cake stack, the C really represents the responsibilities needed by the CNI. If you're running on AWS and you're using VPC CNI, VPC CNI today does do container networking. It does do network policy. It happens to be implemented in eBPF. It's implementation detail, but the point is the CNI needs to provide that base layer of networking and policy. The second is the S in the cake stack is for SPIFFE. SPIFFE is a spec that, actually a few different specs, that is intended to be used to represent what a workload is and have something else verify and validate that. So let me give you an example. Actually, some of us were at some customers this week, a big, huge one out in Texas. And what they would do to establish workload identity today, they're not using SPIFFE or SPIRE, is set up service accounts in Active Directory and give the applications these username and passwords, these long-lived username and passwords, that at runtime, they would use the username and password, exchange it for a JOT token, and then start passing around those JOT tokens. Now, they had 10,000 of these service accounts, and they would store the username and passwords. I think they were using Vault. But the important bit is they would exchange it for these long-lived JOT tokens. These JOT tokens would be handed around and could be leaked. Developers put things in logs, headers all the time. And the InfoSec team was not really happy with having to manage 10,000 Active Directory service accounts and the fact that these username and passwords were everywhere and service and the tokens and so on, all this stuff, right? This is what they were doing to get workload identity. In the SPIFFE and SPIRE case, what we do is use a mechanism of attestation, something that actually goes and checks and says, all right, you're telling me your workload A, I'm going to actually go check that your workload A. So for example, in Kubernetes, the way that we do that is Kubernetes gets deployed with a service account and a service account token. And the SPIFFE implementation will go and say, hey, you're telling me your service A, let me prove that you're running with the service account that represents A. In a VM, it would do something probably slightly different. It would say, hey, you're telling me your service A, and on this machine, I'm actually going to go check the cloud provider that you're actually on this machine, that the process you're telling me is actually on this machine, and actually go check. And just because you have the username and password doesn't mean that you are who you say you are. Right, and now this identity, when it gets assigned, it can get assigned, for example, as a X509 certificate. So that when you use it at connect time on a TCP connection, for example, you know, using PKI and verifying, validating the certs and so on, you can prove that this is the workload. Now, we need a layer that's going to actually use the workload identity and actually implement something with it, like mutual authentication. And this is where the service mesh comes into the picture. Specifically, Istio Ambient mesh. Ambient mesh is a sidecarless implementation of a service mesh. And there's a number of reasons why. So we at Solo and at Google, we help co-create it, and we're leading a lot of this stuff now upstream. The reason why we wanted a sidecarless service mesh is because it's simpler to onboard applications. You don't have to inject sidecars anymore. From a cost and resource planning perspective, there's not that many proxies running now. Instead of, you know, we had plans to run 10,000 pods, you'd have 10,000 proxies. Well, now you don't need to have 10,000 proxies. You can significantly save on resources. We can improve performance. In the sidecar model, where we're using a lot of layer 7 capabilities and parsing the connection and so on, is kind of expensive. But if you don't need layer 7, then we can just bypass that whole layer completely and stay in layer 4, get mutual TLS, get authentication, and improve performance. And so Istio is a full-featured service mesh. We can do other things like locality-aware load balancing and deep telemetry collection on the network. So as soon as you start it, you'll see exactly who's talking with whom. But from a security standpoint, the important bit is it uses workload identity, and we can write policies about the workloads. And all of this, actually, I forgot to mention, but both Cilium and Istio rely on a declarative configuration model. So we can declare what the intention is, what is the security policy supposed to be? And Cilium and Istio can then go reconcile the what the actual network implementation is of that. Here's an example of the ambient mesh architecture, where workloads have been deployed on nodes. Each node has a networking agent that's responsible for handling things like MTLS, using the SPIFFE certs, X509 certs to establish MTLS. We can implement layer 7 capabilities just like we can do in the sidecar approach with a dedicated layer for layer 7 called Waypoint. And what we do is we basically deploy a gateway per service account. A gateway per service type, you could think. And this, we're gonna come back to this, this is actually a very important point. We've been working on Istio and Service Mesh for 7 years in the open source project, but even longer before that. And there's a lot of pros and cons and trade-offs and so on that you can make when you build a service mesh. The sidecar approach was probably the most, I don't know, I don't want to say easiest, but it was the, you know, it was an acceptable set of trade-offs for what we wanted to do at the time. Now with more control, things like eBPF, things like you know, better understanding of how people actually use the service mesh, we can optimize for what the architecture looks like. And if we want to do it without sidecars, we think this is probably your, you know, it comes with the best set of trade-offs. And I'll go into a little bit more detail about that. The last part of the stack, the cake stack, is the Envoy proxy layer. Envoy represents the layer 7 capabilities that we need in the oh, I did not update those bullet points. So Envoy proxy is a open source project started by Lyft. It is in the CNCF, graduated project in the CNCF. A number of organizations contribute to it. A number of organizations have built products, commercial products on top of it. You know, the community has sort of converged around Envoy as that next gen layer 7 proxy. Communities like Nginx at the time, and even still now, as I talked about earlier, were a little bit more closed. Now they're dominated by one single vendor, harder to extend and so on. But so Envoy represents the layer 7 capabilities on which we can build things like API gateways. And those API gateways can then be combined and integrated with the service mesh technology, the underlying CNI technology, run nicely on Kubernetes, as opposed to some of the other proxies, and integrate very nicely with SPIFFE and SPIRE. So if we look at the way platform engineering teams are approaching modernization, they're starting small. They're starting with Kubernetes and containers. They're expanding out. They're including networking. They have to include networking. And we think that the cake stack is an appropriate set of open source technologies that have been built to work nicely together and integrate nicely together, that are based on declarative configuration, workload identity, and standard open integrations, and can be used as the Kubernetes mobile platform starts to grow. Can be used for lift and shift purposes. Can replace some of the existing networking technologies that might be in place, and can even be used in scenarios where you might want to shift but without lifting. So instead of forcing everything into Kubernetes, we can extend the networking pieces out to workloads that might not ever get to Kubernetes. So things like VMs, things like Lambdas, other container environments. You know, we want to try to get as many workloads into this security and networking controlled environment like I said, based on declarative configuration, we're going to identity themselves. All right. I'm going to end on one area where there is overlap between Istio and Cilium. Cilium, like I said, started as a CNI and is a very good CNI. They're, one of the, ISO is the main vendor behind Cilium, or one of them, also started to build a service mesh out of Cilium. And they made some decisions about the architecture that, when we started looking at what a networking stack looks like and what's the right project, what's the right tool for each layer, we just couldn't get behind what they were doing with the service mesh. And I'll explain that. Let me explain it through a demo. All right, let's go into our environment here. Can y'all see that? Okay, right, we're not too far back in the back row. All right, so what we have here is Kubernetes cluster. We have Cilium installed. Actually, if we go to Cube System, we'll see Cilium installed. So Cilium's our CNI here. We have no Istio installed. We don't have anything really else installed. We have a set of applications, very simple applications. Hello World and Sleep. Sleep you can think of as the client. And we're going to call Hello World. Now you'll also see that we have two different versions of Sleep and Hello World. Now, when we think about the connectivity, when we think about the connectivity between those services in a service mesh based on SPIFFE, we want mutual authentication. We want both the services when they connect and talk with each other. Sleep says, hey, I'm the sleep service. Hello World says I'm the Hello World service, and you want to prove it. You want to mutually authenticate when they communicate with each other. Now, Cilium's service mesh does something kind of like that, and I'll explain that. So the first thing we're going to do is we're going to take a look at our workloads, right? Right now, if I try to call the various permutations of the services, they succeed. But we don't want that. We want Sleep v1 to only be able to call Hello World v1. It should not be able to call Hello World v2, and vice versa. All right, so the first thing that we're going to do is we're going to set up a Cilium network policy that says, for the Hello World v1 service can only be called by Sleep v1. Declarative configuration. We're gonna put this policy into place, and we're going to require mutual authentication. And we'll do that in the vice versa also, right, for Sleep and Hello World v2. So now we apply this. We apply these declarative configurations. The network goes and reconciles itself for that. And now what we're going to see is we're going to make those calls again. We should see Hello World v1 can only be called by Sleep v1, and Hello World v2 can only be called by Sleep v2. We're also going to see that under the cover, Cilium is going to do an MTLS connection and establish mutual authentication. So we're going to actually start up Wireshark under their on the bottom pane. So start up Wireshark and we make some calls. And we see on the top pane, Sleep V1 can call. Let's go back to the. We see Hello World V1 can call, or Sleep V1 can call Hello World V1, but cannot call Hello World V2. Sleep V2 cannot call Hello World V1, but can call Hello World V2. And on the bottom pane, we see this this mutual authentication that's happened over MTLS in the Cilium service mesh. Now, here's what actually happens. Cilium is going to create the MTLS connection, which consists of exchanging public keys, public keys, agreeing on private session keys. And the intention in MTLS is to then use those private session keys to continue the conversation, right? So only those two parties can communicate. That's not the case. Cilium ends up closing up this connection right here. And then what it says in the lower layers of the eBPF cache, it says, yeah, it can talk to people. It has no, I mean, it doesn't, this part doesn't say anything about, well, that has to be encrypted. So it can go over plain text. They're mutually authenticated, but they can go over plain text. If you want encryption, then you use something like WireGuard, or IPsec. All right. Now, this is to put my solo hat on for a second. We run with customers in highly compliant environments. FIPS for FedRAMP, for example. WireGuard will never be validated for FIPS. Choose a completely different set of algorithms, different set of ciphers. It won't be validated by FIPS. Bless you. The handoff of the session keys that were created here. Well, there is no handoff actually right now. They throw those keys away. That is a big gap between what you said you're gonna start and continue the session with and what you end up actually doing. So this kind of stuff will not be compliant in FIPS for sure, probably most environments. But there's a even bigger problem. Network policies enforced, that's fine. Let's take a look at the way the Cilium service mesh treats identities. In that mutual TLS handshake, they do use SPIFFE. But like I said, they close up that connection and they throw it away. And they revert to eBPF-based network policies. And those policies are based on a concept in Cilium called the Cilium identity. The Cilium identity, if we take a look at one, is basically, it's just an integer. It's an integer that is, if we take a look at that one, defined by some labels that are assigned to pods and deployments. And in this case, there is only one, what are we looking at? Sleep service. So what we'll see if we look in the eBPF maps down there at the bottom is that we've mapped this integer to an IP address. If we scale up the number of replicas of the Sleep V1 pod, what we'll see is more replicas of the service of this application. And that identity, that integer, we pull up the map again, is now mapped to 15 different IP addresses. Right. Now let's take a look at an example of where I mentioned to you earlier that if IP addresses get recycled, they can get reassigned. And it's actually not that difficult to do that. I mean, I'll simulate this. I'm going to slow it down. But the way this works is the Cilium agent is connecting to the Kube API. And it's watching for changes. On it's being deployed, undeployed, whatever, and it's go update the eBPF maps. Now, I'm going to simulate this dropping that connection between the Cilium agent and the Kube API for the demo. But that kind of network can get interrupted at any time. Or the Cilium agent can get really busy doing something and maybe miss some updates or slow down the updates. Or the clusters are big and the Kube API is really slow and it slows down these updates. So this is not an unusual thing. I mean, like I said, I'm synthetically dropping the work, the connection here, but you know, that can happen in any real cluster. Now we're going to run a test. We're going to run a test where we redeploy, and we look over here. We can see that sleep's being redeployed a couple times. And what we're going to do is we're going to see if we can get an IP address that was once assigned to sleep v1 and see if we can get it assigned to sleep v2. Which would then, and we found one, this IP address. Then that would allow sleep v1 to call hello world, or sorry, sleep v2 to call hello world v1, which is an identity mismatch. That policy routing, that's not what we wanted. So what we want to do is we want to have the identity, workload identity maintained on the connection at the time, you know, we're communicating, and not have it be eventually consistent. We want it to be immediately consistent. And that's what Istio does. So if let's reset this because we're going to install Istio. We're going to install Istio Ambient. We'll give that a second to install. And Istio Ambient is a sidecar-less service mesh. And we'll check that in a second when things stabilize. But when a connection from, in this case, sleep v2 tries to call hello world v1, that will happen on the TCP connection, not consistent somewhere else in an IP map, which we saw on Cilium. Right, so we see, first of all, what do we see? We see Istio is installed. We see the Z-tunnel component that I quickly mentioned that performs the MTLS. It's the agent that runs on each of the hosts. In the default works namespace here, we see all the workloads. We don't see any sidecars. We see 1 out of 1 here, but they are in the mesh. Or on the bottom of the mesh. Let's see. So I did that. We're going to configure the authentication policies, which look like this. Right. So first we're going to say everything's strict MTLS. We're going to say everything gets denied by default. And then we're going to say for hello world v1, only sleep v1 can call it. For hello world v2, only sleep v2 can call it. There's an example of a declarative configuration based on workload identity that we're going to then apply. Right, so now we're going to configure those authorization policies. We're going to include those workloads in the mesh. Right, so now we're going to call the services like we did earlier. That looks good. That failed. That failed. That looks good. Now we're going to try do that trickery where we try to get the pods to get reassigned IP addresses that would enable the connection to go through when it shouldn't. All right, so let's run that again. We'll start by taking down the connection between this particular node and the Kube API. right? Now, let's churn the workloads and wait for an IP address that was once assigned to sleep v2 to be assigned to sleep v, or once assigned to sleep v1 to be assigned to sleep v2. And when we find it, let's try to make the call, sleep v2 to hello world v1. We should see Istio block.
Well, let's hopefully see what happens.
Didn't find it yet, so we'll try it again. All right. So we see we did find the IP address mismatch. We tried to call, tried to violate the policy. It did not succeed. So now we have workload identity based on SPIFFE and SPIRE at runtime, at the connection time, layered on top of Cilium. And we're able to, you know, mitigate this and provide a defense in depth posture for that. But ultimately, the point is there are some architectural differences that we feel are different enough that Istio is the right service mesh for that layer. So I'll end with this. At Solo, we've done a lot of open source training. So if you want to go learn about Cilium, you want to go learn about Istio, Envoy proxy, SPIFFE, networking fundamentals, security fundamentals, and cloud networking, please check out academy.solo.io as a sponsor. That's the only commercial plug that I'll do. But thank you all again for coming out. I know it's late. Do reach out if you have any questions, concerns, whatever. Just happy to follow up on the conversation. And thank you to Joe and the meetup here and the sponsors. And yeah, I'll have a good night.
All right. Yeah. Thanks everybody for coming out. For those of you that this is your first meetup, welcome. Glad to have you. Hope you come back. We try to do this every month, and we're trying to do it every month here, but we'll let you know through meetup.com, through the CNCF community group pages, through Kubernetes Slack, through Tech 404 Slack, all the different ways. We'll let you know when and where and things of that nature. And on that note, the CNCF has a groups page that manages meetup events and things like that, that they're trying to get everybody to move away from meetup.com to use. Our Atlanta Kubernetes meetup has about 3,000 members on meetup.com. And as of right now, there's about 37 on the CNCF community group page. So I put together a survey. It's in the meeting notes that there was a link up to earlier, but if you could just go to github.com/Kate's ATL meetup. If you have the notes in there, you can find the link right there. We'd really appreciate you if you go to that survey. It's like 3 questions. It'd take like 30 seconds, I promise. Don't want to waste your time. Just let us know if you have a big problem with us no longer going through meetup.com. If that's a big deal, we obviously don't want to lose our touch with our community and everything, but double posting is kind of annoying. That being said, again, thank you to SpeedScale, Solo, Georgia Tech, ATDC, and Calendly for sponsoring all the different portions of this meetup event. We're going to have a little bit of social time to hang around and whatnot. I unfortunately have to peace out real quick after this, but feel free to hang around for a little bit, hang out and talk, get to know each other. And thank you again. For those on the call, we're going to stop the recording and hang out. Join us in person next time.